Hi Year 10, our next video on trigonometry is to do with problem solving. So when we're solving problems, we often need to use some different rules that will help us. So there's a nice 6 steps there that, just like I had with the Pythagoras video, that you can use to help. So like before, always draw a diagram, mark on the diagram your unknowns and what you do know, find the right angle, write an equation, solve it, and then if you need to, write your answer in sentence form. Now, some properties here that can help, just like we did, you got your isosceles triangle. Now, some properties of circles and tangents. So, in this first circle, where it says a chord, that is where you just draw a line between 2 points in a circle. Sometimes it's also called a secant, but generally we use the word chord. The radius is the distance from the middle of a circle to the edge. And then a tangent is, you see there on the second diagram, it's a line that touches the circle at one point on the outside. Okay, and that's called a tangent. So you may find with some questions, they'll start talking about tangents, maybe chords. Just refer back to this and you'll know what it means. A lot of problem solving in trig can come down to angles of elevation and depression. So when an object is higher than the observer, the angle of elevation is the angle from the horizontal up to the object. When an object is lower than the observer, the angle of depression is the angle from the horizontal down to the object. It's a nice little diagram here. So you see here your angle of elevation is from the horizontal up and the angle of depression is from the horizontal down. Our first example, we have the following roof has a pitch of 16 degrees. Find the length of the horizontal beam. So we want to find the length of the beam. So what I'm going to do first is we're going to label this beam maybe X, internal, all right? And we look at this and we go, well, that's not a right angle triangle. So we're only doing right angle trigonometry at the moment. But what we could do is, we could split this roof in two, and we can create ourselves a nice little right angle triangle there, okay? And if we do that, that means we have this unknown side here, the half of the beam. So I'm not going to use X, let's use Y. So half of the beam, I'm going to call it Y. And now we can work out what half of it is, and then we just have to times it by 2 to get the full length. So let's look at this triangle. We want to work out what the adjacent side of the angle is. Let's have a look at what we do know. So we've got an angle which is 16 degrees. Do we know the opposite? Nope. Do we know the adjacent? No, but that's what we're trying to find. And do we know the hypotenuse? Yes, we do. It's always the side opposite the right angle, and that's 9.4, which means we're going to use cos. So just a reminder, cos theta equals adjacent over hypotenuse. Now here we're going to have the cos of our angle, so angle is 16. That will equal adjacent, which is y, over our hypotenuse, which is 9.4. We now need to rearrange this. So we're going to have 9.4 times cos 16 will equal y. Put that in your calculator and we'll find that value of y is equal to approximately 9.036. Now to find the total length of the beam, we need to times that by 2 because we've got 2 of those. Now when we're timesing this answer by 2, we've rounded the answer here to get 9.036. I don't want you to use the rounded answer. I need you to use the exact value that your calculator gave you for that previous part of the question and times that by 2. Just it will eliminate any errors with your rounding, okay? So as I said last lesson, the IB doesn't like you to round midway through. There's always a mark for the right answer, and that right answer is always never rounded until the final step. So if you round earlier, you may be out by even just by 0.1 and you still will lose the mark. So if you put that in properly, you'll get 18.1 meters as your final answer. Now something else with your calculators I didn't mention last lesson, if you were doing questions and you were finding all your working out looked correct and you were still getting the wrong answer, your calculator was probably in the wrong mode. So if you look at your calculator, on most of them right at the top, there's always a letter, and generally it would be a D, an R, or a G. For all your questions, we want it to be a D, or you may find it says deg for degrees, R is rad for radians, and you've got GRA, okay? Now, for the moment, we only work in degrees at the moment, so you will need your calculator to have a D or DEG. If it doesn't have that and has one of the other ones, you will get a different answer. This is only for trig, this only affects anything with trigonometry. If you're having problems and you can't work out how to change it, please send me an email, let me know which calculator you've got, and then we can work through a few steps to get that changed so you do get the right answer. Alright, let's move on to a second example. So we've got a point P is 9.5 centimeters from the center C of a circle with radius 2 centimeters. Find the angle between PC and the tangent to the circle from P. Alright, so we know we've got a circle, it tells us. We've got a circle of the center C. So I'll draw a circle. We have a center of this circle. Alright, and that's called C. Then we have a point, which is 9.5 centimeters from the circle. So I'm just going to pick my point here. There's my point. And then it means that this here is going to be 9.5 centimeters. We know this has got a radius of 2. Find the angle between PC and the tangent to the circle from P. So the tangent to the circle from P means we draw a line towards the circle from P, and it is just going to touch the edge of the circle once. So you could either go up or you could go down. It doesn't matter because it's going to be the same distances. But you draw a line and you want it to just touch the circle at one point, like that. And that's what a tangent is. Now we want to find the angle between PC and the tangent. So what that means is we are wanting to find this angle here from PC and the tangent. So this line we've just drawn, the second line we drew is the tangent. So we're trying to find this angle. Now if we do this as well, then you'll find that this here at the tangent is a right angled triangle. And now we have all the information we need. We know that the radius is 2, so this part of the triangle will be 2. And we're wanting to find the angle. So we've got to look at what we know. So from here, we'll see we know the opposite and we know the hypotenuse, which means we are going to be using sine. So sine of the angle equals the opposite, which is 2, divided by 9.5. Now let's work this out. We want to find the angle, which means we need to do the inverse of sine. So it's going to be the sine -1 of 2 divided by 9.5. Put that into your calculator and we'll get that the angle is 12.2 degrees, and that's rounded to 3 significant figures. Alright, so see how, if you hadn't drawn a diagram for that, we wouldn't have known what to do. Alright, but that diagram has helped to solve the problem. We've been able to visualize what we need to find, and we've gone from there. That's all I want to do on the problem solving part. So this will be 13B from your textbook or from your booklets. Make sure you're checking your answers as you go, that you're on the right track. Any questions, send us an email, we'll get back to you, and I'll see you next lesson.